So for this question, we will need to calculate the range of values that cover 68 or 95% range of data for Gaussian distribution. So the other name for Gaussian distribution is bell-shaped curve. So here if you have a bell-shaped curve and we have mean right in the middle. Now just for ease of demonstration, let's say we're talking about USMLE step 1 score and the mean average is 220. Now if we go one standard deviation away from the mean, and let's again for argument's sake say that standard deviation is 15. So if we go one standard deviation away from the mean, the range of data that falls under the curve would be equal to 68%. In other words, 68% of students will get a score somewhere in between 205 and 235. Now what if we go 2 standard deviations away from the mean? And then in that case the range of data that falls under the curve is much bigger, and that would cover 95% of the students. Now for the question here, I would like to calculate the range of data for 68 and 95%. So 68% equals mean plus minus 1 standard deviation, and for 95% it equals mean plus and minus 2 standard deviations. So the question has already given us the standard deviation, which is 7.3. So the question is, what is the mean for these curves? So the mean is the total number of these values added up divided by the sample size. So it equals, we have one patient that had 25 infections plus 2 patients that had 30 plus 3 patients that had 40. And then one last one that had 45, and then divide this whole number by 1, 2, 3, 4, 5, 6, 7. So the sample size is 7, and once we add them up, once we calculate that, it would be 35.7 would be our mean. So let's plug these values in. 35.7 plus and minus 7.3 would give us approximately 28 to 43. So this value covers, this range covers 68% of all the data. And for 95% it would be 35.7 plus and minus 2 times standard deviation, so 14.6, which is approximately 21 to 50. And that covers 95% of all the data. So just to repeat what I explained here, that's the curve that is shown in the text. If we go one standard deviation away from the mean, that covers 68% of all the data. If we go 2 standard deviations away, that would be 95%, and then 3 standard deviation covers 99.7%. So let me ask you a question here. Let's say, for argument's sake, that the average for USMLE step 1 is 220 and the standard deviation is equal 15. The question that I have is that what percentage of students will get a score higher than 250? Alright, now the way that we can answer this question is, so 250 is actually 2 standard deviation away. So we have 220 as a mean. If we go 2 standard deviation away, that would be 250. And if you go another 2 standard deviation back, that would be 190. So this range of data covers 95% of all the students. So the area that is shown here, the one here and the one here, is equal 5%, both of them added up. So both of them added up is equal 5%. Therefore, each of them is 2.5%. So only 2.5% of students will get a score higher than 250, and another 2.5% will get a score lower than 190.